We talked a little bit about probability so far, and we talked about the counting principle as far as how to find the possible outcomes of a situation. Now let's talk about this idea of permutations, and this is going to take the idea where order is going to matter when we do a couple of different ideas. Um, so let's start off with an activity, sort of an example of when we might use a permutation. And I'm gonna change this a little bit. So the activity that they've given me here is talks about the number of chairs, right? We have 3 chairs and we have 3 students. To me, I'm just going to use the chairs, so I'm going to just go ahead and I'll walk you through what this activity is like, and then I'm going to adjust it a little bit. Okay, so it wants to know how many ways one of the 3 students can be chosen to sit in the first chair, have one of the students sit in the first chair, okay? And then what we're going to do is we are going to repeat the step for the second and third chairs, okay? Well, in all reality, what this is saying is if I have 3 chairs, I can just put the chairs in order. So let's talk about all the different ways that we can make these chairs in order. Okay, now when you put them in order, it matters which place they go. So we'll have, we'll do it over here. We'll do the first chair, right? First, and we'll do the second chair, and we'll do the third chair. Okay, and what we'll do is we'll look to see how many choices we can do. Okay, and so let me just make these a little bit smaller here. Okay, so what I'm going to do is I'm just going to go ahead and I'm going to drag these over into the various locations. So if I want to do the first chair, I have 3 options, right? So I'm going to put in, we'll do red, and then for my second choice, I already used the red chair, so now I have to use one of the other 2, so we'll use blue, and then we'll do green, right? And then I'll do it again, and I'll say, okay, the red chair again first, but then I'll do green, and then I'll do blue. Now let's do the same thing. I don't have any more options, right, for the red chair. So now let's do the blue chair first. Blue chair, and then we'll go red and green. And then we'll do it again with blue chair, with green, and then red. And now I'm out of options for my blue chair first. We'll go green chair first, and then we'll do red and blue. And then we'll go ahead and we'll do the last one, green chair, and we'll do blue and then red. Okay, and then when we look at this, we say, okay, how many options do we have for this whole thing? Okay, and so we have 1, 2, 3, 4, 5, 6. We had 6 possible ways, possible ways to arrange these chairs, right? Arrange. This, notice, arrange, order. Arrangement, okay? An arrangement is you're going to have an order to it, okay? So 6 to arrange 3 chairs, okay? Now let's look at this through the eyes of the counting principle, okay? Now remember that what that says is, okay, for each event that you do, you look to see how many choices you're going to have, okay? So in this case, we have how many choices do you have for the first chair? Well, we have 3 choices for the first chair. How many choices do we have for the second chair? Well, once we've used one of them, right? Once I use that red chair in this case, right? I grab this one, it's gone. Now I have 2 choices, okay? And then for that third chair, you look and you say, how many options do you have? Well, you've already used 2 of them, right? 2 of them are gone. You've only got 1 left. So 3 times 2 times 1 is equal to 6. And these are all the different ways that that can happen. Okay? So let's go back and sort of, this is what they said, repeat it, apply the counting principle, right? And so we found the permutation, okay, of 3 chairs, all right? So we can think of it that way, all right? And so a permutation is an arrangement of a group of objects in a particular order, okay? So we're going to take certain things and we're going to put them in order. So there's all different ways you can do this, if you're running a race where you're looking for first, second, and third, right? Or you are running an election for different officers and you have a president, a vice president, and a treasurer, okay? Each of those things is a unique situation, right? First place is different than second place, which is different than third. President is different than vice president, which is different than treasurer. Okay, so those would be permutations where the order does matter. All right. So in this case, let's say we have 6 permutations of the 3 letters of the word cat. Okay, and so they basically just didn't do the same thing. We have CAT, ACT, TCA, CTA. There you go. Okay, so in this case, right? C-A-T, and then they switched those. Started with A, switched those, right? Started with T, C-A, and went on, okay? So, there you have it. 6 different combinations, or 6 different permutations of that letter, of that word, okay? Well, let's go ahead and let's try this, all right? Let's try, if you're in an amusement park, let's say you and 3 of your friends go to an amusement park. How many ways can you stand in line to buy tickets for the rides, okay? So you're going to look at this and we're going to say, all right, how many different ways, or, we're going to, how many ways can we stand in line? Well, all 3, well, let's see, it's you and for 3 of your friends, so there's 4 people, right? And they're asking us to do stand in line, so it's everyone that's standing in line. So we're going to look at how many people can stand first, how many people can stand second, how many would go third, and how many would go fourth, okay? So the first, how many ways can you do? Well, how many choices do you have for the first person? Well, there's 4 people. There are 4 choices. How about for this, for the second location, right? After one person is standing in first, the first person in line, how many people could be second? Well, now you have 3 people here, right? And then the third person in line, there's only 2 choices, and then there's only 1 person at the end. And when you do this, you get 4 times 3 times 2 times 1, okay? Which is going to be 24. So we have 24 different ways that you and 3 friends can stand in line. Okay. So let's erase that, and they're just going to sort of walk us through here. The choices for the first. This is what I just said. Okay. 24 different ways. All right. So now we have another example. Stamp collection. Okay. Let's say there are 52 entries in the 2002 to 2003 Federal Junior Duck Stamp Contest. Random, okay? In how many ways could the first, second, and third places be awarded? All right, well, now what I want you to do is I want you to try to solve this one and think about how many permutations we can get here. All right? All right, so there were 52 entries, right? 52 entries. And we're going to find out how many different ways we can get first, second, and third, okay? So, first, second, third. How many choices can we get for first place? We have 52. How many choices for second? We have 51 because 1 person has already been chosen. Third place, we have 50. All right. So let's go ahead and multiply these out. I'm going to use my calculator here. We've got 52 times 51 times 50. 132,600. Okay. 132,600 ways. So 52 people enter this thing. I have 132,600 different varieties of people that could come, different ways we could get first, second, and third. Okay, so that's a pretty unique, or that's a lot of choices there. So one quick thing, I want to go back to that amusement park problem where the 4 people are standing in line, right? And you're arranging all of them, right? When we had 4 times 3 times 2 times 1. Now, anytime you see this thing where you're using all of your choices and you multiply each number, right? So you start at the total and you multiply by each one all the way down until you get to 1. This is what is called a factorial. Okay, and the way what we do is when we talk about this is we say 4 times 3 times 2 times 1, right? We don't want to write all that stuff, so what you'll see is an exclamation point, okay? So when you see 4 exclamation point or 4, what that means is it's a factorial, okay? And it means 4 times 3 times 2 times 1. So let's try it. If you have 6 factorial, okay, go ahead and you write down what you think this is going to look like if you expand it out, what that actually means. Okay, so hopefully you did pause it, and I'm hoping that you saw that this is 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. All right, and if we multiply this, let's see, let's just do it by hand. We've got, let's see, we can do, let's do 5 times 4 is 20, and then 6 times 6 is 36, so 20 times 36 is 720, okay? So you could think about it this way. You could say Let's say I have we could do the same thing. Let's say I have 6 people in a race, and I want to know all the different ways that I can. How many different ways can they come in? First through sixth. Well, there are 720 different ways that we can get first place through sixth place using 6 people. Okay, and that's what that idea of factorial is. Okay, so what I would like you to do is I'd like you to go to Khan Academy. Oh, you can't see that. Go to Khan Academy, and what I want you to do is I want you to practice permutations. I believe it's permutations 1. Okay, so I'll also link it in PowerSchool, but I'd like you to do that over the weekend and just give it a go, give it a practice, and keep trying. A lot of it is, use your hints, and you'll work your way through it. Okay, good luck.